Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so in today's video, we are going to be comparing the Muxall Pro Barbecue Controller version 3 PCB, a high voltage PCB layout, to the version 4 on the right here. High voltage PCB layout. All right. So version 3 is on the left, version 4 is on the right, and let's get started. There's the layout has changed quite a bit. I think the only thing that didn't change are the header locations, because I didn't want to have to change all in two different boards. So the locations are the same. It looks like all the optocouplers are in the same. You can see them right down here. Sorry, what layer am I on? Back? Let's see, back. Front. Why are they so grayed out? Front, back, bottom. Oh, top. Sorry. There we go. That looks a little better. There we go. Okay, I wondered why everything was so grayed out there. So, it's about 7 o'clock in the morning. I probably just need more coffee, right? So anyway, here's a version 3. Here's a version 4. As you saw on the backside, the headers are pretty much in the same spot. And so the optocouplers are in the same spot. The power supply, that's this guy right here. It's in the same spot. And... but yeah, everything else has changed. I completely relaid out this board. Completely laid out version 4 PCB to support the 240 volt power requirements. Okay, so I increased the trace space. Actually, the trace size is pretty much the same, because I originally was thinking about supporting this on it, but I did increase all the spacing and some of the vias, and especially the spacing that is around the low voltage traces, right? Because we don't want any arcing or migration or whatever other ugly thing can happen when you're running 240 volts AC through these things, right? So I increased the trace space, and then I just rearranged everything. Probably the biggest change I did, and I don't know if I mentioned this in the schematic, I don't think I did, is I changed the capacitor sizes from a 20 nanofarad to let's see if I can get it to pop up, to a 0.1 microfarad, or basically a 10 nanofarad. So it went from a 20 to a 10. It reduced the size of them by half, which kind of makes sense, right? It's got half the capacitance. And I did that because these triacs, if you remember, these are the triacs right here. As you can tell from the version 3, they changed locations a bit, but that has really nothing to do with anything. But these triacs right here are supposed to be snubberless, so I don't really even need the snubber circuit. I added that. And then the other two caps, or the other cap that is for it, is kind of a smoothing cap, if you will, like a bypass cap. If you look at the schematic, if you remember this schematic, and I could pull it up, we can look at it real quick if I still have it up somewhere. Oh, look at that. Well, this is the version 3. Let me see. Here we go. Here's the version 4. Yeah, so here you go. So here's one of the caps. You can see I call it 0.1 mic. I did that because that's how you order them. And on this one right here, it says 20 nanofarad, so you have to do the math, but this is basically 10 nanofarad, 20 nanofarad, and V3. And you can see it's just a bypass cap, right? And this is the snubber circuit cap right here. This, according to the data sheet for the triac, is not even needed, because this is supposed to be a quote-unquote snubberless triac. I went ahead and added a snubber because this is a motor, and that's the fan's a motor, and this right here I probably could leave out, but I didn't anyway. Just as a matter of course, I just don't want to start cheaping out on this thing, right? That is not the goal. Yeah, I reduced the size of those things to for one thing, better fitted on the PCB. These caps right here are ginormous, and they're heavy. They're just huge. So yeah, I'll have to do some testing, make sure everything's okay. This number will be just fine. We'll have to make sure this is enough bypassing for it. So I'll have to do some testing. I'm guessing it will be. There's plenty of the power source to this is going to be pretty easy. I should say the load on this is going to be fairly light. The auger and the fan don't pull a lot. These triacs are rated for 10 amps. So I'm guessing the bypass cap was probably sized for 10 amp load. And the max I'm putting through these is going to be 5 amps. So that kind of makes sense, doesn't it? Half the amps, half the bypass cap size, right? But anyway, we'll do some testing with that, make sure it's going to behave itself. Okay, so what's the other differences? Optocouplers are the same. Triacs are the exact same. I just moved them around, and I changed where the power comes in on the version 3. It's up here, but the switch is down here. I'm sorry, the switch is up here, so I moved its location to down here, closer to the actual switch on the controller, which is on the button panel, actually. And then line in, I just flipped it around to give it some more room, so it's right there next to it. Let's see, what else did we change here? Yeah, basically just move things around. I put the wires, where you solder in the wires for the auger and the fan and the igniter, and I just moved them out, make them easier to access when you're assembling it. And let's see, what else we got here? Let's see, look at the back again. Oops. And so if you've been watching other videos, you're probably getting tired of me talking about this. Yeah, so I connected all the unused header pins to either ground or power supply. Did the same here. Now these look like they're traces for the 240 volt power supply, but yeah, I can talk about that too. I added a output cap for the power supply, a 47 mic electrolytic, and so I beefed up all the power L. See, which one is this? This is the default. That's not helpful. Net 15. Okay. Well, this is probably the 5. In fact, I know it's oh dang nabbit. Let's look on the top. Maybe that'll help. Oh, you can see it right here. So yeah, so here's the 5 volt. Okay. Let's go back to the bottom. So most of the the low voltage stuff I moved to the bottom. And then all the high voltage I left on the top, because remember what I was saying? We needed, to increase the spacing. So I did that. I had to pop up to the top a few times, but mostly I routed all the low voltage on the bottom, and then I tied all the pins. You can see right here's a ground. This is the ground right here. So you can see these 2 pins are tied to ground. These 2 pins. These guys up here are tied to the plus 5 volts. You can see it's coming from this electrolytic cap. So it comes out of the power supply, goes into electrolytic, which gives it, some capacitance in case of a big power need, right? It doesn't pull on the power supply. It just pulls directly from the cap. But anyway, you can see that now instead of having just 1 pin, like in version 3, I had just one measly little trace. It was pretty big. I don't remember what size this thing is. 0.5 millimeter. I don't know what that is in mil, but I definitely increased the size of it, right? I beefed that up a bit. Let's see, what else we got? I tied all the pins. No more disconnected pins are being used for something. And I moved all the voltage to the bottom. Oh yeah, resized the caps. Oh, I remember what I was going to talk about. Go back to the top here. Our new electrolytic. If you watch the schematic video, you know what I'm talking about. There's electrolytic and a 0.1 mic ceramic right here. That's just for the output of the power supply. It's like a buffer, if you will. If you watch the the schematic video, I'm actually rethinking this because I'm not exactly sure it's going to be needed. But I'll leave it there for now. I might do some testing and eliminate it. In version 5, maybe. Who knows? I think I can even probably just leave it off. I'd not even solder them in. I don't think that would be a problem either. Anyway, I think that is it. I don't think there's anything else. Yeah, so really the only differences are the biggest difference is the trace in the space to support the 240 volt power supply, or power voltage, or mains voltage, let's say. Okay, and then this cap right here, which I'm now questioning if I should even leave it. So there you have it. Hope you enjoyed this video. If you have any questions, let me know, and I'll talk to you later. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.